So what I'd like for you to do is take out your 2-2 notes. I'd like for you to label it 2-2 on the top right, day and the date on the top left. This should be Friday, October 11th. I'd like for you to complete this while listening to it. We're going to talk about this paper and then something else about graphing, and then the expectation is that after this, you are working on the reflection assignment, 2.2 assignment. Okay. So things that are important here. What is a reflection? So a reflection of a line, we're going to call it M, exists if every point P gets mapped onto P prime where the following are true. So if P is not a point on the line of reflection right here, it's not on this line, then line M is perpendicular, is a perpendicular bisector. So from here to P prime, where we can see it's perpendicular, it's at a 90-degree angle, and it bisects this segment that connects it. If point P is on the line of reflection right here, then we say that P is equal to P prime. So I want you to think about like your nose being on a mirror. When you put your nose on the mirror, when you if you can look into it, it looks like it is touching, but it's on, in this case, on the line of reflection. Right over here, these are just various notations to represent reflections along a variety of lines on the coordinate plane. So most common ones here are probably x and y axis, this line, which is x equal to y, or y equal to x, or y equal to x is this diagonal line like this. The reflection of x equal to +3, so this right here, I'm going to highlight that in red. That looks like this. It is +3 on the x-axis, and it is a vertical line. But we're going to talk more about this at the end. Okay, but we need to have a good understanding of where these lines lie in the coordinate plane. And then you have some other things. We have line segments and lines. Okay, so what are some properties that reflections have? So we're saying that if we reflect something from line M, in this case right here, that triangle ABC is congruent to triangle A prime, B prime, C prime, and we can see that here. First thing we're going to fill out is 1A. So every point on the preimage has a point in the image with the same distance from we call that line the line of reflection. Later in this unit, we'll talk about line of symmetry. That just means left side looks like the right side, and that is true here. B, points farther away from the line of reflection move a greater distance. So we would say that A to A prime, that distance is greater than B to B prime. So all we're saying here, this is further away from this line. So that means A prime is further away to the right of that line compared to B. And as we can see, this line segment that connects our preimage to our image of A to A prime is longer than this line segment from B to B prime. Okay. Another thing that we'll see that's in common here, these points are equidistant, but segments are parallel, connecting each corresponding part. That's never going to intersect with that, nor this. So always going to be parallel here. And also the orientation is reversed. What do we mean by that? So I'll take my red pen here. As you can see in this triangle, if we go in alphabetical order, I do want you to annotate this. Right? If we go from A, B, C, now if I go the same in the same order, but our primes, right? A, B, C, we're going in reverse order. So this is a property that reflections have. It reverses our orientation. As you can see off to the left, this was a clockwise direction, and now this is CCW, counterclockwise direction. So that's a property that it has. Next one is, we're actually not going to do the construction here, but very briefly, right? Perpendicular lines, lines that intersect at a right angle. Right, we already talked about it, but as you can see here, right, perpendicular lines, right angle right there. Perpendicular bisector is a line segment, is a line perpendicular to a segment at the segments right over here. What do we call that in terms of A and B? We've talked about this before. This is the midpoint. I'll abbreviate there. This for constructions, we would use a compass and protractor. We might get to that later, maybe when I come back. But for right now, we'll leave it as is. So we're gonna skip this now to the back side, please. All right. Now, the graphing examples, I would prefer you to pause the video, or maybe we'll go through the first one together. Pause the video, see if you can do it, and then once you completed it, then play the video and see if you got it correct. Okay, so for the first one, we'll do this together. Obviously. Should say the grid to reflect the following figures over their respective line, M. So when you look at this, we can use a variety of tools, but we're just going to use distances here. As you can see, let's start with C here. From the line of reflection, this is 1 to the right. So from the line, we're going to reverse that. It's now going to be still 1, but 1 to the left. So right over here, we're going to label this as C prime. A, also 1 to the right, keeping that same height. This is going to be 1 to the left. Let's label that A prime. And then last one, 1, 2. B is 2 to the right. So from here, 1, 2 to the left. We're going to call that B prime. And just do the best that we can to connect all vertices of this triangle. Yeah, and this is exactly the same as the right. Well, it's congruent, same shape, same size. So yeah, for this, ask yourself, if it's a line like this, right, how far is the pre-image left or right of that line? And you're just going to reverse the direction from that line. Okay, here, same thing, but we have a horizontal line. It looks like they're all above, so reverse it. It's now going to go all below. And this one here, a little bit different now that we have diagonal lines, but we'll talk about it when we get to it. I like for you to pause the video at this point, try the other two figures. I'm gonna give you like 2 seconds and then I'll resume. All right, so we have this figure, JKPLM. I'm just gonna go ahead and graph this. So this is J prime, so we had something that's 1 above, it's now 1 below. M is 1 above, and that's also 1 below. Since J connects to M, J prime will connect to M prime. Let's go with J also connects to K. So K is 1, 2, 3 above. So 1, 2, 3 below. Let's go and connect or draw K prime right here. Okay. P prime will be right here. It looks like our last point. Whoops. Right, L, 1, 2 above, 1, 2 below, right over here. All right, so let's call this L prime, and then when you connect all these corresponding parts, yeah. Like if you want, not that you should, but if you were to fold your paper along this line of reflection, you would have that this figure would map onto this figure, right? Okay, so same thing over here. Well, not same thing, it's diagonal, but keep in mind that I'm gonna draw these lines, I'm gonna get rid of them. Let's go with this. So K with the line of reflection should intersect at a 90-degree angle. Let's do the same thing for M. Same thing for L. And not that you should, but if you were to measure this distance, right, we would go that same distance right or upwards and right of this. So if you're not sure, this is K prime. Right over here, we've got, what is that? This is M prime. And then L prime, I think, far right. I'm gonna erase these red lines here. If we connect them all, if you look straight down that line of reflection, line M, you're gonna find that these are two congruent triangles. So this is looking at it in a more intuitive sense, right? We're counting distance and we're reversing that from the line of reflection. Math is all about being efficient. So we're gonna hopefully notice some things with now these coordinate rules or coordinates and develop a rule here. So these are specific to these common lines of reflection, that being the y-axis, x-axis, and the line y equal to x. I would encourage you to use a highlighter and really emphasize those lines of reflections here, so you know where you're reflecting it from. Okay, so let's go, and I guess we'll go in order. The pre-image points are already drawn for you. You're welcome. So let's go with A. So A is 1, 2, 3 to the right, 1, 2, 3 to the left. So this is A prime. So let's go to write that coordinate. That coordinate is -3, +4. B right over here, it's 1 to the left, so now let's go 1 to the right. So this is B prime. That is 1, 5. 1, 5. 1, 2, 3, 4, 5. Yep. And then we've got C prime. That is -2, -1. Okay. Now, it's at this point that I'd like for you to discover this. You all are analytical, and you all can engage in critical thinking. Is what do we notice from here to here? There's a lot of things that we have in common, but what changed? So let's look at the first one here. And I'd encourage you to pause the video and try to answer this for yourself. So if we look at 3, 4, this is -3, +4. Right? -1, 5, +1, +5. And last one, 2, -1 is -2, -1. The question, there's two questions here. What is the same and what is different? So the things that we see that are different here, I'm gonna use my highlighter, are all of the X values. So what happens with a reflection along the Y-axis? Yes, you can count it and reverse it, but this is the coordinate rule. X and Y becomes -X, +Y. What this means, or what this doesn't mean, this doesn't mean make all the X's negative, right? This X is not negative. This negative in front just means make it the opposite. So to summarize this rule, when we reflect along the Y-axis, you change the other variable, X. So reflect from the Y-axis, you change the X variable. So if I look at, let's say I give you a point, let's say 9, -4, and we know we're reflecting from the X-axis or Y-axis, you change the X. So this would be -9, -4. Okay, I'm gonna erase that because we don't need it. All right, next one. So at this point, I like for you to graph it and then figure out if you can identify the rule and then resume the video after that. Okay, so give me 2 seconds to pause it and then resume afterwards. 1, 2, okay. Now, if you're not pausing it, I'm just telling you to pause it, but make sure you're pausing it. All right, so A is 3, -5. So this is definitely down. This is below at 5, so we're going to go up 5. So it's going to be somewhere right here. Let's go with right there. That is 3, 5. And we're putting double prime, so this is a double prime. It technically should be a singular prime. It's a double prime is if I were to, let's say for A, reflect this and then reflect it again. Okay, then it would be double prime, but we'll keep it here just for simplicity's sake. Next one, B is -4, -2. -4, -2. So right over here, it's 2 below, so it's now 2 above. B prime is -4, +2, and 0, 4 is now 0, -4. Okay. You don't have to do this, but maybe this makes more sense. If we were to connect our pre-image points, maybe we can see how the reflection is happening. If I connect, oh, did I not label A prime? Right, maybe put your pencil right on that line of reflection, and you'll see, right, the left side should look like the right side. Okay, anyways, you don't actually have to connect it, but to check this a little bit, I'll put this in blue. Corresponding parts are parallel. Those that are further away, it's like a interesting geometric design. Nice. Okay, I'm gonna get rid of these lines though. All right. So what is the rule? So we can think of the last one. We reflect from the y-axis, we change the x. We reflect from the x-axis. What do we think is happening? -5 becomes +5, -2 is +2, +4 is -4. It is the y's that are changing. So reflect from the y-axis, we change, from the x-axis, we change the y. All right, so that means y is going to be opposite. I'll put x opposite over here. All right, great. And then now moving on to our last one. Last one, right, whenever we go through diagonal lines, a little bit harder to internalize, but just do the best you can. We're going to draw, right, if you want, not that you have to. I'll put this thin, I'll put this in red, I'll put it in blue. Right, think of a line that's perpendicular to this red line. Maybe that right there, maybe blue. What's a perpendicular line? Something like that. Yeah, I think I'm not entirely happy with that one. Or the last one, actually. Or the middle one. Let's go with... I think that's a little bit better. Okay. All right, so what are these points? Where are they going to be? So let's start with A prime. A is at 5, -2. So I guess a triple prime or just A prime in that case. That's going to be right over, a little bit off here. I'm just going to call that A prime. That is at the coordinate -2, +5. 0 or -3, 0 is now going to be right over here. That is B prime, which is 0, -3. And C, all at the very top of quadrant 1. This is 2, 6. It's going to be at the coordinate 6, 2 right here. So for C prime, so 6, 2. So again, 2 questions. What do we see is the same and what is different from each line? So 5, -2 is -2, 5. -3, 0, 0, -3. 2, 6, 6, 2. And I think we can see from there when we have our x and y, what we're doing is we are switching. So instead of x comma y, it's y comma x. Whatever our first thing is now our second thing, and vice versa. So for this is just a switch. Okay. So not too bad there. So I imagine you'll have some problems where you can actually reflect it. But let's go to this last part, and then there's going to be one more thing that I show. All right. So determining a line of reflection. So triangle A prime, B prime, C prime is the image. So this is the new thing. This was the old thing. Of triangle ABC under reflection, we're going to draw the line of reflection. So how we can do that if we don't know where the line of reflection is, connect corresponding parts and find the midpoint. So I'm going to do this with, if you have, maybe use a highlighter here or some other utensil. If I connect corresponding parts, let me put this in pink. I should probably pick green, at least a different color with some contrast. So what we could do is you could use the midpoint formula, right? You could use that this point is, you know what, I guess we can do that for one of them. You can find the midpoint of this and this. You know what, let's do that. Let's do that for A to A prime. So A to A prime, or that segment. Okay. So A is -5, 0. A prime is -3, 4. The midpoint of a segment, is, we're adding our x's and dividing by 2, so -5 plus a -3 divided by 2. And our y's, 0 plus 4, also divided by 2. This is -8, and that in half is -4. And over here, this is 4 divided by 2, which is 2. So the coordinate, -4, +2 is right over, let's go with this. So that is 4 left and 2 up. And notice how it is on this purple line. I mean, we could have easily just looked at this and identified, yeah, that's sure, that's in the middle. But let's go and identify the other ones. So the midpoint of from B to B prime looks like it's over there. And the midpoint of this is, or C to C prime is over here. So at this point, it looks like all these dots are collinear, as they should. They run perpendicular to our line that is connecting corresponding parts. Let's draw a line here. Now this problem just requires that we draw the line, and we accomplished that. But I do want to give us what is the equation of the line. That not necessary, but I think it's important to connect this from what we're working on now to Algebra 1 standards. So the equation of a line, we know that to be y equal to mx plus b, where m is our slope and b is our y-intercept. Okay, so let's find those things with this bold black line. I like to start with our y-intercept because that's on the y-axis. This line crosses the y-axis at this point, so that is 0. So I'm going to put b equal to 0. Our slope, we get to pick any two good points that are on this line and find our rise and our run. I'll use this green. Let's go right here and right here, find our rise, find our run. We're climbing up 2 and 4 left, and that's a negative direction. So this will be 2, -4. Now simplifying this and still keeping it as a proper fraction is negative. We can put the negative in front of our fraction, -1/2. And to write this now, we're going to replace this. This will be y equal to -1/2x plus 0. You don't actually need that plus 0, so the equation of this is y equal to -1/2x as our final answer. Not required, but this is more just kind of a challenge here. All right. So we know how to write an equation in slope-intercept form for the line of reflection. I do want to, this next part you don't have to draw, but I just want to include this. We have a coordinate grid. Just so you know, what is the equation of, let's say, this line right here? For a vertical line, you find it where it crosses the x-axis. This is just the equation, x equal to -4. Just like for this one right here, it crosses at positive, right, the x-axis right here. This would be x equal to +3. And then let's go with maybe some horizontal lines. Let's say this one right here. That crosses at +1. Since it's a horizontal line, this will be y equal to 1. The question is, why is that equal? Why is it y equal to 1? If you were to pick a bunch of points on here, let's say that one, that one, that one, you may notice that all these things, the y value is 1. That's why the equation is y equal to 1. And then just one more, let's go with that one. It crosses at -5, so y equal to -5. Okay, so you're going to see something like this in your assignment where you're going to identify what is the line of reflection or what other image are you gathering from the given pre-image. But yeah, let me know if you have any questions. Going to begin your assignment, which is in your packet, the 2.2 reflection assignment. All right, good luck. Let me know if you have questions.